Hello, management finance students. This is Dr. Robinson writing. I just wanted to, well, I guess speaking at this point, right? I just wanted to maybe just do a quick little philosophical note on what's actually happening when you're using your financial calculator or Excel, and maybe clear up some, or maybe make things a little easier to put in context, just based on what I've seen in the homework and the quizzes. I think we could maybe use a little bit of help conceptualizing what's happening when we're solving these kind of questions. So I have here, I can't stream you my financial calculator, so I've sort of created a poor man's version here. But I've got those, 5 buttons that are gray and march right across the middle of your TIBA2 Plus. And we're going to think about solving some simple questions. So what we're doing when we are calculating time value of money is really shifting funds through time using the appropriate interest rate. So, for example, if I have $100 in my pocket today, and someone were to say, well, hey, I'll give you $123 in 2 years, risk free, if you give me that $100 right now. Well, the question is that a good deal? Is this a good investment? Right? We're getting a 23% return over 2 years, right? 23% over 2 years. So, is that good or not? So that's kind of the point of all of this. And what we're doing is realizing that because one can collect interest at the market rate of interest, money through time has an equivalence curve. So if I have 10%, if the market rate of interest is 10% per year, that means $100 today is the same as 110 in 1 year, right? Because I'll earn 10% on that 100. And then in 2 years, it's equivalent to 121, right? That $100 earns another $10, and the $10 earns $1, making 11 total, and we get to 121. So all of these numbers are equivalent. $100 today, 121 in 2 years. You can think of them as exactly the same. And the reason, and so, and there are physically reliable ways of converting between them. So if you were to receive $121 in 2 years, say from a savings bond, you could find someone to buy it for 100 because they could, say, borrow 121 from the bank, collateralize it with the savings bond, and get everything to net out. There's a little bit of friction there, but in general, if you've got risk-free debt, it's as good as cash, sort of regardless of when it shows up. And so we can convert money in any time frame to any different time frame. And this is actually important because if I'm comparing this 100 to 123, I can't really tell which is better, right? On its face, certainly 123 is more than 100, but it's not maybe enough more. How would we know? Well, the problem is that 100 is 0-year money and 123 is 2-year money. So what we need to do is convert 100 to 2-year money. And we would use that during using the present interest rate of 10%. So that 100 is going to change to 110 and then 121. Okay, now we're comparing apples to apples. I could get $121 in 2 years if I were to buy a 2-year savings bond, or I could get $123 in 2 years from this opportunity. So clearly this one here is in my best interest. That would be a good choice. So in general, we're converting funds in random years, collapsing it down to a particular year. It could be year 0, it could be at the end of the project, year 4, year 8. Often we use the present, today, year 0, because it's a common thing we're interested in. And also, if I was taking something from, say, year 3 to year 5, it's sometimes easier just to go back to 0 and then go up from there. So if I had 121 in year 2 and I wanted to know what year 3 would be, one solution would be to take 121 back to 100 and then take 100 up to year 3. All right, so let's talk about how that influences what happens in the financial calculator. So let's say I have, let's say I'm going to get 121 in 2 years. Well, that would be, in the calculator, that would be 121 as my FV. Let's say there's no intervening payments, and the interest rate is 10% a year, and N is we have to set in time periods. Okay, so this is 2 years. This is 10% 2 years, so we'll do 2. Now, what if this 10% rate isn't 10% per year, but it's 10% per year compounded semi-annually, like a bond? Well, in that case, we're doing semi-annual units, so now our time has to be 4, right? We have 4 6-month periods in our 2 years, and we're getting 10% per year compounded semi-annually, so that means we get 5% per 6 months. So that's the step that we're having trouble with. You can, with the calculator, you can do whatever time scale you want. You could do 2 months, you could do 18 days, it doesn't matter. The point is that you need to have the right number of periods for that time period you chose, in this case, 4 6-month periods, and the right interest rate. Every 6 months we get 5% because we're getting 10% per year compounded semi-annually. Then we would compute, hit the compute button and find out what the PV is. So in general, for doing a bond, we will often have these semi-annual things. So if it's a 2-year bond, or let's say a 4-year bond, we might have 8 payments, then this is going to be whatever your yield to maturity is divided by, divided by 2. Divided by 2. And then that, the normal rate, so the interest, the yield to maturity actually. And then the future value will be the face value of the bond. The payment is the coupon, which is probably the coupon rate divided by 2 times the face value, which is almost always $1,000, and then that value is almost always 1,000. Now, what if we had a bond that paid quarterly payments instead of half-year payments? This goes to 16, right? 4 years, 4 quarters per year, 16. We divide the yield to maturity by 4. The coupon rate we divide by 4 and multiply by 1,000. And that would actually end up making it worth just slightly more money because it's better to compound more frequently. So yeah, just philosophically, that's what's going on. Hopefully that you found that a little helpful, and feel free to email me any questions, and I'd love to help. Okay, thanks.